Today we will start BGP protocol, BGP, and BGP. So actually, BGP stands for Border Gateway Routing Protocol. Border Gateway Protocol. BGP stands for Border Gateway Protocol. So first, we will discuss so where we will use and what is the requirement of BGP and BGP is a which kind of routing protocol. So, as we discussed earlier, we do have two types of major routing protocols. One is IGP, and apart from that, we have a EGP. So, IGP stands for Interior Gateway Protocol, EGP stands for Exterior Gateway Protocol. So, basically, and EGP and IGP. So, first of all, within same area, if we are using a same area, if on the same AS, apart from that, inside the organization, inside the organization, inside the we are using the BGP protocol. It means inside means again the same organization. So same AS and within the same AS, we'll use IGP protocols. So for that, we have a, some IGP protocols, RIP, Routing Information Protocol, EAGRP. Apart from that, OSPF, and we have ISIS. These are the IGP protocols. This protocol will work within the same AS numbers. So already we discussed till up to years. So now we'll start to discuss EGP protocols. And EGP will work different. Here it will work on different AS. It means between the, it means so between the two organizations or between the ISPs, between the different organizations. So here we'll use BGP protocol between the organizations, between the organizations we'll use. So for that we have only the protocol that is BGP border. So you can check here name itself. It will be border.
डोसा खाता है
So
नाश्ते में
it's kind
हम्म
of one router we have R1.
हम्म
So it is an edge
क्या
router. Mute yourself, guys. So
क्या खाता
here
बोलो
we have a
क्या क्या सस कर रहे हैं बाप तुम
mute yourself. So we have a it's kind of one edge router. This one is an edge router. So in edge router, it's kind of our branch router. This is the one branch router. It means core router, core or edge, whichever you can call. So it will be connected to some ISPs, Internet Service Providers. So in this router, mostly we will use the BGP protocol. So now I'll explain you the devices, how they are connected. It's kind of architecture of topology. So here it will be connected some switches. It's L3 switch, and these L3 switches are connected from L2 switches. So here mostly what we will do here VLANs will create, and this VLANs connected to some multiple users, multiple PCs. This is a user, a PC, or IP phone, or any server, anything. It's kind of host device. This kind of host device. These all are the host devices. Host means end users, whichever we are we are using PCs or servers, for applications. So those comes under host. So this host will be connected to multi-layer switch. It means we are using here trunk or something in between trunk or something. And here we'll use IGP protocols, IGP, because this router not a capable of BGP protocols. This router, this L3 switches will use, will spend some less price. So these devices not capable of these devices not maintain the lacks of prefixes. These routers, these switches, L3 switches not maintain the lacks of prefixes. So that's why we'll use some OSPF or any IGP protocol in this we'll use. And BGP will use here. BGP will use here. So, but here we are using different protocol and here we are using the different protocol. So some user are at different branch. You can assume this is your branch to R2. So same scenario, here also same architecture, likewise, whichever we are using here, same AS, you can assume this one is the same because this is IBM company. You are working in IBM. So here they are using like 6500 AS number, 6500 AS number. So same AS they'll use here also. So in ISP, internet service providers, they will use different AS number. So here we have a 6500 same. So AS is same. So this is a different branch. And here ISPs are using some different AS. That is the public AS numbers you can assume. This is a public AS. So that is 100. So here we are using private AS. So as we discussed earlier, private AS range we have, public AS we have. So now this different branch wants to communicate this branch. Here we are using again IGP protocols and we are using here BGP protocol. BGP. So here what happened? It's kind of the device. It's like 44 Cisco ISR 4461. The series of this router and this series is 3650 or it's kind of catalyst 9200 switch, 9200 switch. It's 92 or 93. So it is a ISR 4461 router. So what happened when here we are using, as we told, OSPF, that is IGP protocol, OSPF protocol, OSPF protocol. So here also same thing. So for that we have a concept. If you want to advertise this prefixes into this router, so what we will do basically, we will redistribute these prefixes into BGP protocol. That is a redistribution concept. Redistribution concept we have redistribution. So OSPF to BGP and BGP to OSPF, we will redistribute the prefixes. So easily these LAN prefixes will get in this edge router. So anyway, that is the advanced topic, but you should have to know the entire architecture of network devices where we will use. So BGP mostly we will use at edge routers. So for that, we have again two different BGP neighborships. In that also two different, here not a two different types of BGP. Neighborship is different. One is IBGP, another one is we have a different neighborship, that is EBGP. So for that, EBGP again work same AS. This will be work same AS number and EBGP protocol. EBGP protocol will work at different AS. So this one is the same AS and this one is different AS. This one is two different types of neighborship we have. So for that, we will use, if we want to, we are using here same AS means this one is the same AS and this one is the same AS. So if our, even though we have different locations, the branches, but that time also we'll use same AS because we want to communicate within the organization network, that is IBM. So for that, we have to transfer the traffic over internet. We are transferring our traffic over internet. So here we have a different AS concept will be required. So here we need a different AS numbers required. Though that time in between ISP to our LAN network, our organization network, we will use eBGP neighborship. So IBGP and eBGP, two neighborship concepts we have in BGP protocol. First one is IBGP. It will be work within AS number. Within AS number, again, IBGP uses the AD value, administrator distance value, express roughness of the route path selection process. It will be selecting the path. First one is metric. It will be check the highest prefix, longest prefix, or it after then it will be check the AD values. Then it will be move to the metric. Then it will be move to the ECMP, equal cost multipath. Multipath. So likewise, we have a AD values also. In this AD values, IGP will use 200 and eBGP will use AD value, administrative distance value, that is 20. You have to know this AD values. We have a two different AD values. So here we have IGP will use 200 and eBGP will use 20. So I believe everyone understand the scenario and devices where we'll use the BGP protocol, why we require the BGP protocol, and why we'll discuss why it is the path vector routing protocol. Actually, BGP is the only protocol. It is a path vector routing protocol. It is a path vector routing protocol. It's a path vector. It's a path vector routing protocol. Why we'll discuss later on session, later on discussion. The path vector routing protocol. We will discuss those things. But here we have these are the link state routing protocol. OSPF is a link state routing protocol and it's a hybrid routing protocol. And this one is the distance vector routing protocol. This one is a distance vector. This one is a hybrid or advanced distance vector. This one is a link state routing protocol. It's a link state routing protocol. This one also link state routing protocol. And these are the IGP protocols, means it will be work within the same AS inside the organization. EGP will work between the AS, means two different AS and two different organization, two different AS. So different, if we want to communicate over the internet at our different location branch, so we need a BGP protocol. In that also we have a two neighborships, IBGP and eBGP, and say IBGP when we'll use same, if we are using the same as that time we'll use the IGP protocol, interior border gateway routing protocol, and eBGP stands for exterior border gateway protocol. Border, it's a border, not a BGP stands for Bharatiya Janata Party. Okay, not a BJP. It's a BGP
Very
protocol.
good.
Fine. And it will be used as a different AS. It different AS means that time will use to if you want to communicate over the internet, if you want to communicate different branch to over the internet, that time will use eBGP. So different AS and AD values here we have 220. Good. If you have any questions, ask me please. This is the basic concept of BGP routing protocol. So theoretically, something we'll discuss now. So BGP stands for Border Gateway Protocol, and it is open standard protocol. What does it mean? Open standard means it will be work Cisco devices as well as non-Cisco also. It will be work in Cisco devices also, non-Cisco also, non-Cisco, whichever that Aruba, Juniper, any non-Cisco device also, HP, entire networking devices, it will be work. And it is EGP protocol, EGP type protocol, where two different AS number devices can do the communication with each other. So two different AS is that is the reason exterior gateway protocol. So the INA who will provide the AS number actually, who will provide the AS number? INA, Internet Assigned Number Authority, responsible for the allocating the AS number. So we have a range numbers. In that range, again we have a two types of AS. One is a public AS, another one is private AS. The public AS number, the RIR, Regional Internet Registry, they will provide. In that also in INA, one organization is there. Uh, is the responsible to provide to us this. So we have to buy this AS number. So for private AS numbers, these are the free of cost, like whichever we are using the LAN network IP addresses, those are the private IP addresses, same likewise. We can use free of cost. So it is a path vector routing protocol, means it checks the path attribute to reach the destination, not any metric like IGP protocols. It will be used as a path vector. So we have some weight attribute and local preference attribute. So some attributes we have, based on the attributes, it will be select the best path. So from source and destination, we have some path. So this is my destination. Here the destination is there. So we have different path, first path and second path and third path. Here the my destination is there. In between we are using BGP. So likewise they are connected. So we have a three path, one, two, three. So based on the path vector. So for that we have a local preference, weight, and origin code. Some attributes we have, based on that attributes, it will be select the best path. Anyway, we'll discuss later on that. So, and it is a layer 7 protocol. It will be work in application layer. It is a layer 7 protocol. And BGP only the protocol we have, that is a TCP based routing protocol, transmission control protocol. It means here we have a some port number also, it will be used. So it is a protocol only. It will be used as a three-way handshake. It will be send a sync packet, and after then this will give the sync plus add. This one is a sync. It will be give the sync plus add, and this router will give the acknowledgement. So here we'll get the acknowledgement. With acknowledgement means router 1 and router 2, they will establish a TCP connection, three-way handshake connection, for reliability purpose. So whichever this router is originating some packets, so this router will give the acknowledgement. R2 will give the acknowledgement. That is the reason it is a TCP based routing protocol. And that for that it will be used 179 port number. The port number is here why we required, means it will be identify the service. So it is a reliable protocol of TCP. It is, that is the reason it's a reliable protocol. So here again by default maximum path is one. So as we discussed, so if we have different paths from source to destination, BGP only the protocol, it will be not perform the balancing. It will be not perform the load balancing. If you want, yes, we can achieve, but the maximum path is only one. Only one path it will be select. Based on that only it will be send the traffic. Based on the path attribute, it will select the best path. It will be maintained only one path from source to destination. This is the source and this one is the destination. From source to destination, it will be used only the one path only. It will be not perform the load balancing. But IGP protocols, they will maintain up to four paths. They will maintain in routing table up to four paths. The BGP, it will be maintained only single path. So again, it's classless routing protocol. What does that mean? Classless routing protocol. So classless means we have a prefix here. So this is the destination prefix we have slash 24 and slash 25 and slash 26. So whichever the prefixes of subnetting, so it will be carry. It will be carry with subnet mask. It will be carry with subnet mask. So that is the reason it's classless routing protocol. And by default, auto summary will be disabled. So what does that mean, auto summary? So here we have one prefix 192.168 dot. It's one dot zero. This is the one prefix 24. So here we have same 192.168.2.0 slash 24. We have multiple like 3.0 and 4.0 like this many prefixes. If we want to advertise, it is maintain the much more routing table. So for that, we will do summarization. Just instead of the 24, we'll use summarization. 22 something we'll use. Then we'll summarize the prefixes. So it will be by default disabled. Some auto summary will be disabled in BGP protocol. If you want, yes, we can enable it. So instead of 192.168.0.0, we'll use likewise. So if you want to communicate in the only way that prefix only visible like only one prefix, we can summarize the our routing table. So if we have thousands of prefixes, so the routing table also big. If you want to filter the routing table, then we'll use the summarization basically. So it will be disabled by default in BGP. If you want enable, yes, we can enable it. So by default, and by default, load balancing will be disabled. Yes, load balancing also disabled. If you want, yes, we can enable it. And it has a two AD values, 20 and 200. 200 for the prefix, 200 for internal prefix. So internal IGP protocol will use 200 and external eBGP will use. Here we discussed already 200 for the IBGP and the eBGP for 20. And so in case of BGP protocol, routes send all unicast messages. So basically, what we are doing in BGP protocol, why it is sending unicast, why we don't have the concept of multicast. So why we don't have the concept? See guys, it's important thing. Just listen here. So it has only unicast messages. So by default, whenever we are using the BGP protocol, it will not form the neighborship in between two routers dynamically. BGP is not a dynamic routing protocol, guys. Listen properly. It's not a, this one is not a Dynamic protocol. It's not a dynamic routing protocol. It is a static routing. Again, we are statically formed the neighborship. We are formed statically neighborship. How? See, R1 here and R2 here. So different location, whatever. If you want to configure BGP, will inform through, hey, R1, your neighbor is R2. How will inform like, hey, R1, a R1 router, your neighbor is this one. Statically, we are telling. If this router is indirectly connected also, if between AS also, between ISP also, we can achieve the neighborship in between statically. So statically we are configuring. That is the reason here we don't have the concept of multicast. So it will be send unicast messages only. Unicast messages only. One-to-one communication will be happen. And this TCP based routing protocol. That is the reason it is a TCP based routing protocol. For TCP reliable connection, it will be used 179 TCP port number 179 TCP port number will be used TCP port number 179. And statically we are configuring how. I'll I'll show you in lab, but one neighbor command, hey, your neighbor is 2.2.2.2, and that remote AS is like will give 200 likewise. If we are configuring EBGP, if we are configuring EBGP, that time will give the different AS. This is a 2.2.2 is a this loop back IP address or connected directly connected interface or whichever. We can form the indirect neighborship also. We can form the direct neighborship also through neighbor command. Again, if you want to advertise the prefix, we will use network command. Network after then we'll use something 192 line prefix means 192.168.10.0 and we'll give the mask. Likewise, then we'll advertise 255, 255, 255. Likewise, we'll advertise the prefixes. So likewise, we'll advertise the network prefix. But earlier, when we configure IGP protocol, that time only this network command that is sufficient. They can form the dynamically neighborship. Just what we did earlier, just router, OSPF, and we'll give some 100 is the process ID. Then just we'll give likewise the whichever the directly connected interfaces will just will advertise through network command. Yes, they can form the neighborship. But here this is the command through we can form the neighborship through neighbor command. Hi. Here also we should have to tell, hey neighbor 1.1.1.1 and remote AS like remote AS is remote AS autonomous system is 100. This is the EBGP configuration. So statically we are telling this right routers statically. So that is the reason here we don't have a multi-cast concept. Anyway, I'll show you in lab how we'll configure, how we'll form the neighborship, how we will form the neighborship. I'll show you in lab. So in case of BGP protocol, routers send all unicast messages towards each other because there is no concept of multicast address. So BGP does not support the concept of dynamic neighborship. Yes, yes, understood. The BGP protocol will not support the dynamic neighborship. We have to configure statically because it does not use any multicast IP address. Yes. So it will be not use any multicast IP address. That is the reason we have to statically enable. We have to statically inform to my neighbor. You are my neighbor. So we can only form static neighborship between the routers. So we can form only static neighborship only. So BGP can maintain lakhs of prefixes. Yes, because inside the routing table, it will be maintain the lakhs of routing protocols. As I told here, so here through ISP we are coming. So in this branch too, if we have multiple departments means so thousand prefixes here and here thousand prefixes. This router should have to maintain which router this are to maintain even though these prefixes also and thousand departments means thousand user connectivities means this router should maintain these prefixes also and locally originated prefixes also locally originated local prefixes also and remote prefixes also, remote branch prefixes also. So that is the reason it will be used there. It will be maintained in routing table lakhs of prefixes. As I told, that is the reason in distribution switches or L3 switches, we will not use a BGP protocol. If it is a capable, means it's 90 to 100 means yes, it is a capable of BGP. It is a fastly switch. Catalyst 9200, 9300. So yes, if you want to use, yes, you can use here also because that is the based on the vary which device we are using. So if uh, 96, 90, 3200 if you are using here, sir, if you are using here 3650 or something, catalyst 3650. So if you are configuring the BGP, so over WAN, the lakhs of prefixes are coming in this router. So this L3 devices will not much more CPU utilization we cannot use at a time. So it will be hang the devices. If you are increasing the load, it means so BGP the only protocol it will be maintain the lakhs of prefixes in routing table. So wherever other IGP type routing protocols can maintain thousands of prefixes only. So again, this is all about the BGP protocol. Yes, if you have any questions, ask me.
This is the main reason why we are using BGP protocol for neighbor switching.
Pardon again.
No, what's the main reason we are using this BGP protocol for neighbor switching? Because it can have the lakhs of prefixes inside this routing table.
Yes, it will maintain the lakhs of prefixes in BGP routing table. So that is the reason we are using this core devices. So we will redistribute this IGP to EGP. So even though if we are redistribute the prefixes, it will maintain, it will be redistributed means it will look like this router will believe, this R2 branch will believe I am getting the prefix, not a IGP protocol. It will be believe like I am getting the prefix over the internet. That is the prefix also BGP prefix. So that is the reason we will redistribute our entire land prefixes to
And in
EGP.
real time, how we do know this is the suitable protocol for the current situation, and this is not. This is suitable.
So basically, here we have a IGP as we discussed. So IGP we have interior gateway routing protocol and it's EGP for exterior gateway routing protocol. So basically, which one is the suitable where we will use means so if we are using the within AS, so within AS means definitely you can use OSPF or ISIS or EAGRP or
With the
this
same
protocol. If
AS.
you within the same AS, if you want to configure different AS, so we have a protocol that is EBGP. So based on the AS, we can verify it. Based on the AS numbers, autonomous system numbers, we can verify which protocol where we have to use. Again, we have a two neighborships in BGP also, IBGP as well, EBGP. So BGP is having two neighborship. This is not a type of BGP. This one is a not a type. This is a neighborship type. Okay.
Yeah, I got it.
Good.
ఎక్కడ
So concept
తెల్లలా
where we use BGP protocol. Oh yes. Mirza, here is the concept also
వచ్చిందా అది
where we can
Yeah.
use the BGP protocol. Guys, mute
Yeah.
yourself. If you are not, if you have
రేపు
any
వర్షం
questions,
పడుతున్నాయి
tell me out. Okay, I have muted. So BGP can maintain lakhs of prefixes inside the BGP routing protocol. That is the reason we are using BGP routing protocol. And we use this concept on enterprise network. Enterprise means our whichever the IBM. Those are the enterprise network. Our Wipro,
The big ones.
big one organization. So again, we'll discuss some network types are there. We'll discuss that time you can understand the entire thing, the BGP protocol. So in if you are using small organization, that is a small organization, that time not required for the BGP also. And I'll discuss those things here. So now move to the on ISP router. As we discussed here, definitely the internet service providers, if they are not using BGP routing protocol means, so they cannot able to commu- uh, they cannot establish a connection between two different branches. Here they have customer type is IBM means they have a one customer that is IBM. If ISP providers are not using BGP protocol means they cannot establish a connection between two different branches. So ISP also must they will use the BGP protocol. So to make a communication possible between two different ISPs also. So most probably here you are seated, you are having one branch is Hyderabad location. You have a one branch in US location. So single ISP is not possible because here in India having different companies. Those are the Jio, Airtel Bharati, and we have a government organization like BSNL something. We have a different ISP providers in India location, in Hyderabad location, and US location some Verizon, AT&T. Those are the different ISPs. Like this is a Verizon ISP. This is one is a Hyderabad. That is a BSNL. So in between multiple, even though multiple ISPs are there, I'm not denying. So the connection will be likewise also it will be happen. So the connection will be likewise also it will be happen in between. They will connect likewise. So between AS also, between two different ISPs also, they will use the concept of BGP. If to make a communication possible between two different ISPs also, internet service providers. That time also we need BGP protocol. The requirement of where we'll use the BGP protocol. This is in this organization we'll use. Now here we have some customer types. Here we have some customer types. So here we have some customer types in BGP. So single homed customer type and dual homed customer type, and we have a so here we have a four different customer types: single homed customer type, dual homed customer type, single multi homed customer type, and dual multi homed customer type. So we'll discuss first of all one by one. So single homed customer type means first single homed customer type means you have only one edge router, and edge router is connected one LAN, and this is one LAN. This is LAN network, and this is the edge router, and this edge router is connected. one ISP, one ISP provider, internet service provider, and this ISP connected some internet something, internet or Google something, wherever. So this is connected like this again. So this this LAN user wants to reach a Google. So just we can use this is a VLAN something. Here we can use concept, and in this edge router, if we are using the some any routing protocol IGP, yes, we can use. So because in between the communication only. So here we'll use some NAT service, network address translation. So for that, the private IP addresses, private to public IS, public, it will be converted. NAT, it stands for network address translation. Basically, NAT is a protocol we have, network address translation. What it will be do? It will be convert from private to public, public to private. So in this single forward customer type, not required because it's a small organization. It's a small organization. Only here we have 100 users. 100 users. It means only one VLAN we are using. Only one VLAN or something. If you are not using the VLAN, also not required. So basically, we'll use VLAN and all. So it's a single. This user, 100 users wants to communicate internet or Google somewhere, cloud or somewhere. The cloud connectivity, cloud in the cloud they hosted their websites. Definitely they can use the single home customer type. Here the BGP protocol is not required. Here we have a only 100 user means only single prefix that is 192.168 and something whichever the public private IP we can use. Yes, in this case not required. If we are using BGP protocol, so you need some AS numbers and all. So not required also in this case. Now move to the dual home customer type. The same scenario, dual home customer type. So here we have one LAN network. We have a one LAN network. This LAN having multiple users. We can assume 100 or 200, and this one are connected like. But in this scenario, we are using redundancy ISPs. Redundancy ISPs. If any ISPs goes down, these are the dual home customer. So here we have internet. This one is our branch router or something. So this is the LAN network. So here we have a ISP one, and here we have a ISP two. It's a dual homed customer type, and this one also small organization. This one also small organization. So not required here also. In this scenario also, in this customer type also, not required the BGP protocol. So single homed customer type, dual homed customer type. Now, it's, here it's a branch single multi-homed customer type. What is that? Single multi-homed customer type. Here, now we have a here redundancy. So here the problem is this ISP goes down. We don't have a redundancy ISP. They cannot reach the internet. The problem is here once this ISP goes down, so they cannot able to communicate the internet. They cannot communicate over cloud or somewhere because only one ISP they are using. So that is the reason they are using now d- dual homed dual homed customer type means they are using redundancy ISPs. Redundancy ISP means one ISP goes down, so they have a redundancy path. Why they are using? Here they are using 1 gig link and here they are using 100 Mbps link. 100 Mbps link. So one link this goes down also, we have another ISP. So the LAN user cannot fail the through connectivity of internet. So they can easily communicate. So small organization, they will use mostly this kind of network type. They will use this kind of customer type network. But it's kind of if there is a big organization, so that time how they will use. So here we have now dual home customer type. Here single multi-homed customer type. We have two routers and we have LAN connectivity and this LAN connected likewise and this is a LAN network we have. This is a LAN network connected to multiple hosts or something. They are connected. Now single ISP they are using. Single ISP even though they have connectivity like so mostly customers they will use here HSRP, hot standby redundancy routing protocol. It's a gateway load balancing protocol. And the requirement is here the BGP protocol. This is a single multi-homed customer type. Because if this router is goes down also, they have a different IS, different router. What happened in this scenario? If LAN or they can communicate easily. But if this router is goes down, yes, they cannot able to connect because this LAN physical devices goes down. Here, no redundancy part. Here we have a redundancy part. Even though what happened, this router physical issue is there, anything, so we cannot able to form neighbors. We cannot able to communicate our internet. But in this scenario, we have a R1 and R2 routers. If one router is goes down, also we have another part. So this is what single multi-homed customer type. Yes, here we will use BGP routing protocol. Yes, definitely we'll use BGP routing protocol. This setup, this scenario is in some branch offices, this setup will be happening. Again, what about the dual multi-homed customer type? In this, only we have a single ISP, but here we'll use entire dual. So two routers, mostly we'll use two core routers, and this two core router is connected to different ISPs and likewise. So this is our LAN. So user cannot they will cannot face any LAN user. They cannot fail. They cannot feel any connectivity issue because here the ISP goes down, so they cannot able to reach again anywhere. They cannot able to reach anywhere. So ISP only single ISP. So here one ISP goes down also. We have a dependency path, different ISP. This is a dual multi-homed customer type. These all are the customer type, and mostly we'll use here BGP routing protocol in this scenario, and BGP protocol will use here. And these all are the organizations, small organization network type. So this is all about the customer types. You can go through the theory. Same thing is there. And here there are two types of neighborship in BGP. As I told, in BGP, we have a two types of neighborship. One is IBGP neighborship and one is eBGP neighborship. As we discussed here earlier, starting only, we have a two types of neighborship in BGP protocol. So IBGP stands for interior border gateway protocol and eBGP stands for exterior border gateway protocol and BGP neighborship within the same AS. router receive from IBGP peer is internal routes. It will be used as the very value, and it will be used external routes, and it will be used the 20. It will be work in different AS numbers, separate autonomous system numbers, EBGP. And this is all about the BGP. And we have some message types in BGP routing protocol. In types of messages, open message, keep alive message, and update message, and notification message, route refresh message. So when it will be used? So open message. So whenever the neighborship form in between two routers, router 1 and router 2, we configure statically neighborship BGP. So the time they will establish a neighborship between two routers, R1 and R2. Then they will neighborship form once. This message will not send periodically between routers. It will be not sent periodically means after every time some any neighborship or anything is there, it will be not sent a periodic updates. It will be sent only for first time to whenever the BGP neighborship form, that time only the message will be sent. After neighborship form, they will send the keep alive messages. Open message only first time they will send, that is neighborship message actually. Hey, you are the my neighbor or not? They will sent to each other. Yes, I am the your neighbor, and yes, I am the your neighbor. Once they form the neighborship, Once they form the neighborship, every 60 seconds, they will send, hey, you are alive or not? You are alive or not? They every 60 seconds, they will send the keep alive message. Every 60 seconds, they will send the keep alive message. Once he is not giving the reply on this 60 seconds, this router will wait three times. It means 60 plus 60 plus 60, that is 180. It will wait till 180, that is dead timer. This is a hello timer, and this one is a dead timer. If 180 second also it is not giving, then neighbors will be flashed. This router will flash that neighborship. It means neighborship is gone. In that, they will send in open message, that is the content of they will send to each other, and keep alive messages every 60 seconds they will send. Once entire they will form the neighborship, they will send prefixes through update message. It will send after getting any new update in the topology. Again, if any updates also, that time they will send update message. Then content message, entire prefixes they will send. It means whichever they once they form the neighborship, this router having 100 prefixes, in that content they will share that information also. How many prefixes are there and which version they are using, length of size, and hold on timer, and entire prefixes information also they will share. If any new prefix came, if any new prefix we added again, that time on that update message they will share. It means it's a new kind of new update. And any neighborship went down, anything happened, they will send notification message. They will send notification message. In that notification message, it's kind of log. It's kind of error detection. Anything error are there, any neighborship is goes down, any prefixes are not readable. So then they will send it's a notification message. And apart from that, we have a route refresh message. So whenever if any neighbors, any prefixes we added, any prefixes we added, or any prefixes we removed, or anything happened, that time it will be hard reset. One option is there. If we not, it will be takes us some time. That is based on the route refresh message. They will send the update. If we not did hard reset something, it's kind of advanced topics. So this is all about the message types. and in BGP we have a some it will be maintained the types of routing table. In case of BGP, it will be maintained three types of routing tables. On that neighbor table, yes, as usual, neighbor table is there, and BGP routing table is there. BGP table, that is routing table BGP of specific routing table. Apart from that, we have a global routing table. I'll show you. This is in lab. This one I'll show you in lab. How we will check show IP BGP summary. It means how we will check the neighborship table, how we will check the BGP routing table, how we will check the global routing table. But here you should have to know the BGP maintains three routing tables in that BGP neighbor table, BGP routing table, BGP and global routing table. So these all are the advanced topics and how the BGP will loop avoidance mechanism, how they will avoid the loops. Apart from that, here we have some states, ideal state, state, active states, open send message, and open confirm and establish. These are the states we have. So basically, I'll quick overview. I'll give the overview. Ideal message means ideal state means we enabled BGP on this router we haven't enabled. This router start to send the ideal message means you we can not configured here. So that is a ideal state. I'll show you ideal state how it will look like. So through BGP summary command we can check this ideal message. So connect means once we configured BGP in between two routers, so they will start to send our entire prefixes that is connect state. Once the connection TCP means it will be used to send the connection TCP port number 179. They establish a neighborship connection in between through TCP handshake, three-way handshake. If three-way handshake is fail, if three-way handshake is failed some reason, because AS number here you configure something AS, you are planning to configure here 200 and here you are planning to configure 100. But you configure remote AS is different. Here you configure this is the remote and neighbor and you configure 300 instead of 100. So AS is mismatched. That time it will be not established a BGP neighborship. So are you have configured wrong IP address, wrong prefixes, wrong IP address of directly connected. If you are configuring some mismatched IP addresses, that time it will be moved to the active state because here TCP connection is not forming and activity will be moved again ideal state. Ideal means nothing. The neighborship is not formed in between. If the TCP connection entire is proper, then it will move to the open send message. Then they will share each other to some prefixes, whichever the prefixes have. The LAN prefixes they will share open send and open confirm also. They will each other to confirm it. Once they confirm, the establish. Establish means yes, the neighborship is formed in between. Established state means if active means the neighborship is not formed. Active means it's not a good. Active means it's not a good in BGP actually. Established means it's a good. They form the neighborship. They formed the neighborship. I'll show you. I'll verify it in lab. Anyway, this is all about the BGP and we have some path attributes here. So some path attributes based on this path attributes, BGP will work. Next hope, it's the not J, remove this. Next hope, the AS path origin local preference. So here we have a mandatory and discriminatory and transitive and non-transitive. And these are the discretionary, mandatory, and transitive and non-transitive. These are the prefixes. So these are the attributes. So basically, it will be work based on this. It will be selected based on the shortest path based on this row. First one next hope it will be checked, then it will be check the weight, then it will be check the local preference, then it will be check the self advertiser, then it will be check the AFR, then it will be check the origin code, then it will be check the med. Med is nothing but again metric only, and it will be check the external over internal. It will check the IGP, it will check the oldest path. So entire it based on this they will check, and so if we have multiple paths from source to destination, first it will check the next hope. Then it will be move to the weight something. So weight instead of next hope is good. So it will be sent all time pocket like this. This is the format they will work. This is the path attributes actually. So that's it. Entire BGP done. So now we'll move to lab. We'll discuss. If you have any questions, yes, you can feel free to ask me in BGP routing protocol. So today we discussed here the BGP concept, and BGP is advanced topic. Basically, it's not in CCNA level. So this is all about the BGP border gateway routing protocol. If you have any questions, yes, you can ask me.